Hello friends, today we discuss about the cryptography. Cryptography is a method to secure your data or valuable information from the network attack. If you are transferring your information from one end to another end, from client to server, or you perform some banking transactions, definitely we want to be secure our data from the attackers or the hackers. In the network, they can sniff our data and they can steal some valuable information like the transaction detail, passwords, etc. So the cryptography is a way to secure things. So in today's video, we will see about the cryptography methods and various flavors of cryptography. And the purpose of cryptography to save our data from the intruders, intermediate hackers. So sometimes if you see that particular figure, sometimes Andy is sending data, but Eve steal that data in between and change that data and send to the SAM. Okay. For example, Andy is sending, hi, how are you? But Eve steal the data and ask the SAM, please transfer $1,000 to me. If SAM believes on that message because it's come from Andy's mail ID or Andy's message system. So if believe and if he can send that $100 and if he asks again Andy, where is my money? So Andy have no clue what's going on. That is the hacking that happen in between. So what Eve will do, he can simply read the packet and change the content. Okay, he just replace the things and send to the SAM. Everything is same. So in a network layer, he just manipulate the data packet, not the header file. So header file is same. So it goes there and the SAM believes it's come from Andy. So that type of attacks happen if your data is not secure. So to prevent this thing, we need a security thing. So that security definitely happen with the cryptography. So cryptography is a way where we can change or encrypt our data and send to our friend or the receiver, and receiver knows how to decrypt it. So in basically we have some terminologies related to the cryptography, like plain text, that means the actual matter that we are going to be sent. Cipher text is an encrypted message that we are going to be changed. That is not a original message. Encryption is a method to generate the cipher text, and decryption is a method to convert cipher text again into the plain text. So our friend knows what is the plain text and they can receive it. Okay, so if we have an encryption and decryption, so definitely our data should be secure. So normal user or the normal hackers cannot identify the content of the data and they will never decrypt our message. So our data is safe, our message is safe. But we need a strong algorithm because, as I told you earlier, there is a black cat community as well as a white hat community. So there is a red cat fight. Black hat person always try to break your security and white hat person always try to make security foolproof. So that thing can happen. So it depends on the algorithm, what algorithm or programming logic you are going to be used to encrypt or decrypt, that matters. So once you have a plain text, you just encrypt it, send to your open network, that is the internet. Your receiver have the key or the no method how to break that thing, and he can read the message. Okay, so there are various standards also with there. For example, in the last lab we see the transposition method. The transposition method, we just rearrange the manners of the words, how they are coming into in the syllabus, how they will manage. Okay, so but if I am an attacker, so if I see the packet and I can rearrange the things in the several times, at least one of the things I will get through, because I know these are the conventional methods. People can use the transposition, people can add something. Okay, so to avoid that thing, people may use the double strength encryption. That means you have a two layer of encryption. First, we have encrypt one thing with the one method. Again, we apply another round of the encryption or another method for the decryption so our data will be secured betterly. Okay. So in the double, as the name suggests, double strength means the label, the first layer and second layer. So we first create a ciphertext generated from the original text. Okay. So and then we generate the hash digest. Hash digest means suppose we have a data, okay, data of 100 words or 200 words, and or some pages. We can encrypt it and generate a hash of that particular data. Hash, I think all of you know, hash is a kind of number, okay, that we use for the indexing purpose, and for your security we are also creating the hash. You can use any of the method to create the hash. Maybe you are using the XOR function or any binary conversion function. So you have one key and you can XOR that key with all the words. So you will get another digit or another number. You can compress the data and generate the hash key. It's up to the implementation, what type of hash you want to be generate. Okay, so once you have a hash, so you have double layer things happen, the encrypted data and the hash data. Okay, and then we apply the same thing again and again, the calculate the hash, or you can send it the things, and this thing should be transferred through the SSL or TLS layer. SSL layer, basically in a computer networks, as you know, there are 7-layer architecture. Basically in TCP/IP we follow the only 5 layers. Okay, so the TCP layer, the network protocol, basically they use this SSL, secure socket layer. Okay, so they implemented that type of security. So in a network, if attackers read your packet, they can read the header part only, but they can't touch your data part because it's secured through the SSL layer. Okay, so if you want to be experiment this thing in the next lab, we will see some Wireshark thing. Okay, so but you know, you have a system. I think all of you have a Linux operating system in your machine. Am I right? All of you have a Linux operating system in your machine. If it is not, then at least you install the VM and install the Linux. So we will see the things how. Yeah. Okay. So how the virus, how you can capture the packet, how things are going on. Okay. So the DS is a double strength encryption. So DSE, double strength encryption, DSE. So you can make any kind of layer of security and your data should be transferred over there. Okay. So the things come into the picture is that what type of key we are going to be used, because key plays an important role. If I am using a 4-word or 5-word letter or 100 words of letter for hashing, and my friend is using the same hashing thing, there is a symmetric key. So, but the problem with the symmetric key is that if attacker knows anyhow, he can make combination and he knows. So he can decrypt all the message that we are going to pass. So there are various approaches to generate the key, because keys are important one. You know, if you have a key, you can open a lock. Simple thing. If you don't have a key, so you can't open the lock. So in a cryptography thing, the key is important one. So there are two kind of keys available with us. That is symmetric key and asymmetric key. Okay. As you see the hierarchy, symmetric key means the keyword or what is the method, how we can encrypt the things. Because one thing is algorithm, how we can make the arrangement. Okay. That is what keyword we are using for the hashing. That is the algorithm. And second one is a key. What key we are putting into the algorithm, so we will get the encrypt key. If we talk about a symmetric key, we have some classical approaches like transposition substitution. The last lab we seen. Okay, in the substitution we have monoalphabetic, polyalphabetic. That means we are replacing with single word, single letter, or multiple letters. So there are the Caesar cipher, beginner cipher. We already seen the beginner. We also did the lab for the beginner, na? So Caesar cipher says that one character is replaced by A, or A is always replaced by C. That is Caesar cipher. But in a beginner cipher, we create a table. So maybe one time A is replaced by D and another time A is replaced by F, something else. So that is a beginner cipher. We already seen these two things in the last lab. Symmetric key, we have some modern approaches also. That means we have a stream of the character and we will encrypt with some encryption algorithm, RC4 and others, or instead of taking character by character, you can take a block by block, a whole paragraph, we can take a whole page, we can take and generate the production, that is AES and DES standards, data encryption standards and advanced encryption standards. And if we want to be more security, but all these symmetric keys are breakable. There are various ways to break all kind of this thing. It depends on the key size, depends on the algorithm, because these algorithms are well known, and it's only about the key, whatever key you are going to be used. So there is another method, is asymmetric key. So asymmetric key, the very famous and common name that is available, that is RSA. People are thinking the RSA is unbreakable because it uses two different keys. One is for the encryption, one is for the decryption. There is a concept of public and private keys. So the meaning of the two keys is that if I am going to be encrypted, I am using the either public key or private key, and other end, the receiver end, will use the opposite. If I am using private key for encryption, he will use public key for decryption. If I am using public key for encryption, the other end will use the private key for the decryption. So we have two different keys. Public key means it is known by everyone, all authorized person. There is one authority who generates the keys. Okay, for example, if you are downloading the product of Microsoft, they will give you the key. Sometimes if they will provide you the private key, or they will allow that keys in internet, so you can know the public key, you can download that key from the website and encrypt your software license. Okay, so that thing can happen. RSA is definitely a most important innovation kind of thing in a cyber security. So mathematically, it is impossible to break the RSA because the key size is too large. Okay, and it's difficult to figure out what key is going to be used. But as I told you in a first class, people claim they break RSA, but their RSA, whenever they break the RSA, their key size is limited, 128 bit or 256. But if your key size is higher than 512, just 2 to the power 9, then it is almost difficult, because if you try to all brute force attack, it will take more than hundreds of years to break it. But another possibility to break RSA is a side channel attack. Okay, we already discussed side channel attack in the previous one. That means if somebody is having monitoring software like Pegasus or some other, so they can listen your cache and they figure out what keys you are pressing whenever you want to be decrypt. So on the key press stroke, they will easily identify what you are going to be search. But it need a expertise. It's not a naive user task. If you have that much expertise or that much knowledge, or you are that much sound in a mathematics also, then you can break the RSA. So RSA is right now many banks and others people are also using for the security purpose, because it is not that much easy as we talk. It is too difficult, because you have a mathematically sound as well as the programmatically you have to be sound, and you have a right in other system to install the software and everything. But it is possible, you can break the things. Okay, so first we discuss about the symmetric key algorithm. Okay, as we know, we have a plain text. We create one key. Key means the transposition, or we are replacing one character with another character, one block with another block of word or hash table. So we have a cipher text, and the cipher text will go to the receiver and if receiver have an exact key, secret key, then he can decrypt it. So that thing is easier one for you. You already experimented all the things, the transposition, the Caesar cipher, the beginner cipher, etc. Okay, so transposition cipher is the one kind of symmetric key transposition thing. So in the transposition, we have a 2D table. Okay, we are keeping words in a row wise and printing them in a column wise. If you see the print here, HELLO, hello, WORLD, world, hello world. We are keeping all the words in the row manner, and whenever you want to be transmit, it will take the column wise, HOL, then EWD, LOLR, and we'll transfer it. Our receiver's friend knows what is the method we are going to be used, that is a transposition. Okay, another way to perform the transposition cipher, we are adding something. Suppose we have one thing hard, okay, and we have one key, so we'll add that key in a word. We can add some additional word in that. Okay, so there are various things. You can use the filler, you can add the things, you add the keywords, you can use the modulus function to generate the new words. Okay, simple way how to implement the encryption in transposition cipher. The simplest way to implement it is just create a two-dimensional array, as we did in the last class. Take things in a row manner and print in a column manner. So that is your encryption, and in a decryption side, again you take the whatever input we have, you can decrypt it again the reverse order. Whatever input you have, you just transfer it, make it. Okay. Now the substitution cipher. Substitution cipher means we are replacing our words with some other thing. Okay. Suppose the word is gray fox has arrived. So instead of G, we are simply replacing U. See, there are two matrices. One is the plain text matrix, another is the replacement matrix. So replacement matrix is our key, started with Q. Okay, that is basically nothing but your keyboard, your laptop or system's keyboard setting. QWERTY something. If you see your keyboard, started with Q, W, E, R, T, Y, and ended with the M. So we replace A with the Q, B with the W, or you can use any keys. So your things will become converted into a different manner. But in this, all the cipher techniques, the problem is that the frequency of a word. Normally in an English word, A, E, I, these are coming very frequently. So if you are repeating these things several times, people knows, okay, maybe this thing may be E, this thing may be O, so they can crack it easily. Okay, that is substitution. The common example of substitution is a Caesar cipher. It's also called the monoalphabetic cipher. That means each letter is replaced by another letter. That is the substitution cipher, the Caesar cipher. Okay. So that is, I'll give you one plain text. You can read a character. You have a one replacement matrix or the key matrix. You can replace it with that. Either you can add +1, you can subtract +1 or something. So you will know the character. Okay, polyalphabetic, there is a beginner cipher. Beginner cipher, as I already explained you in a lab, we have a table. Okay, 26 out of 26 started with A, B, C, D, etc. So we have a replacement matrix. What words or keywords we are going to be replaced. We already seen the polyalphabetic in the lab. Now the next one is the base 64 encoding. Basically, from here we'll start the something that is some strength. Earlier algorithm that we discussed, they are the old days or very much historic algorithms. So now these days they are not used. They are just the beginning, how to start the encryption or decryption. Okay. So the base 64 is a mathematical way. I think all of you know about the base 2. Whenever you convert a decimal number into the binary, base 8, base 16. The same way we have a 64-bit encoding. That encoding converts a binary data into text format. Okay. So if you convert with the bit base 64, it will give you some characters and some numbers, everything. Or whenever you pass this thing through the communication channel, so data will transfer safely. This is also known as a PAM, Privacy Enhanced Electronic Mail. Initially, it is used for the email encryption decryption. Okay. So, but this algorithm stores the password in database. So, the fundamentally or the mathematically, it is, if you know the mathematics or how to create the base, you can easily make the input. You have to give the input and it will give you the output. In the same way, you can perform the encryption. Same way, you can perform the decryption. But if your algorithm is leak and people knows how you are creating the thing, so it is difficult one. Encryption through the XOR process. XORing, that means if you know the when a binary numbers, if you XOR with a number 1 with 1, it will become a 0, 0, 0 is 0, 1, 0 is 1, and 0, 1 is 1. And if you repeat the XOR again, you will get the same word again. That means if you do the XOR of two numbers with the same time, you can get the original number also. But you know the key. XORing need a key. So XORing algorithm is for encryption and decryption, convert the plain text into the ASCII format. Okay, it is fast in computation, so it is easily understandable and implementable. And it is difficult to figure out the brute force attack until you don't have a key. If you have a key, you can easily figure out. Until it is difficult to figure out what is the actual key. That is a XOR. Okay, so next is a multiple cipher. But before that, if you have any query or something, you can ask. It's clear now what these are the very simple and fundamental things. We can easily understand. You can easily understand what we have to do. If you write in a paper and pen some letter and try to replace it, you can easily figure out the things. Multiple ciphers, that means you have you are going to be wrap your words with the various methodologies. If the number will be used for the multiplicative procedure and then associated with the key, then you can generate a more secure cipher. For example, if you have one alphabet, we multiply that alphabet with some key number. Suppose number is 3, 4, 5, any number, and the letter is A. So if you assign A is 1 and you have a 3, A into 3 is will become 3. You take the modulus, so it will give another numeric value. So it will generate a new kind of cipher. And so we are applying two things here: the multiplying with the key and taking the modulus. That is called a multiplicative cipher. And your text will convert in another word. And then the same, if we go with the reverse procedure, you will get the correct method. Okay, so basically we talk about the cryptography. So cryptography is basically divides in two different labels. That means we are using something predefined standard thing. Simply use the things, we don't have to do anything much more. That is one way. Another way is the low level cryptographic primitive. That means we have to take the decision. We will try our own algorithm or our own methodologies to make the things difficult or complicated. So each one have a different kind of algorithm, and each one have a various combination of the things. But the common things that come into the cryptography is a ciphertext, message digest, that is the hash. Message digest nothing but the hash. Key function. Always we are including these ingredients in our cryptographic algorithm to make a good recipe or to make a good dish. So we combine all the things come in the fornet. Fornet is also known as symmetric encryption. Okay. If you remember in the last lab we did the multiple fernet and fernet. Fernet is nothing but it is using a secret key in an implementation. It's a symmetric way, but it uses another cryptographic method inside the algorithm. So it guarantees that the message encrypted using it cannot be manipulated or read without the key. You need a specific key. Okay, so fernet is an implementation of symmetric authenticated cryptography. It also supports for implementing fernet. So inside that thing you can use another combination. Most of the time AES are used in that AES algorithm. Okay, advanced encryption standard is used in the fernet. Okay, so in a key encryption decryption thing, the stream cipher is coming to the picture. Stream and block cipher, we talk about the whenever we saw the hierarchy, and there's a stream cipher and a block cipher. Stream cipher, that means we are reading key by key or the keyboard stroke by the keyboard stroke and transfer that thing into the another character, and we create our cipher text. So whatever key is pressing, it is come to the stream cipher, it will generate a new word and send it to the receiver. And a block cipher, what happened? In a block cipher, we have a plain text. We read all the plain text at the one stretch, give it to the algorithm. Okay, the algorithm have one key. With the key and the plain text, we generate a new cipher text. Okay, so and that cipher text will transfer through the internet. That ciphered or encrypted block is sending toward the network, and we also send the keys with a different channel. Okay, and the receiver will have the key, it will decrypt it and read the plain text. So the very first algorithm is there is a DES, data encryption algorithm. So we have a 64-bit matter or the plain text. Okay, we are using 56-bit key. See the 56-bit key, that means you have 56 different characters. Okay, any number, anything in the range. And one block we are taking it size of 64-bit. That means 64 bits you have. 1010 something, that is a message. 56 bits the key. We'll encrypt that key and generate a 64-bit cipher text. So initial message 64-bit, cipher text 64-bit, but it is integrated thus 56-bit key. So if you understand this thing, you are merging with it, and okay, and 64-bit is basically after each 8-bit we are adding one parity bit, so it will become a 64-bit. 56 plus 8 parity, it will become 64. So each bit is combined with that, and we know the parity, and we have a data. So basically, whenever we talk about the encryption, how the encryption will take place. So in a DS, basically what happened, we have 64-bit input. Okay, and this algorithm will perform various permutations. Permutation, that means we rearrange the initial word. So we have one initial vector which tell us how to permutate the thing. For example, the first bit is going to the last one, second one is going to the first position. That is one initial vector position. We will decide the permutation. That means we are reshuffling all the things, and we perform the merging or the hashing with the keys. Of this now this key will merge with it, or you can use the XORing function, you can use the hashing function. It's depend on the algorithm what you are going to be doing. So we'll generate the various key pattern and various rounds. So we have a 16 round of the merging of keys. Then we swap the keys again. Permutations perform again. That is a long process how the DES will work. And once everything is happened, we have at the end a secured data. Okay, so you don't need to worried about the whole procedure or things. Okay, if the course is related to the network security, then it is important for you. My purpose is that to give you things. The only drawback of this algorithm is that the key size, because if you merge a key and AES algorithm is publicly available, if your key size is small, like 56 bit, so if an attacker applies a brute force attack and try to perform the permutation against with any 56-bit key, so maybe within a 3-4 days he will get the correct message. So your algorithm going to be cracked, because algorithm is known by all of the people. Only the important thing is the key, because key is a secret. So this algorithm has a only drawback is the key size. Now then after there's a AES architecture. It's again a block wise. Okay, DES have a different approach. It's going to work with a bit by bit. Then AES work with a block by block. So we have a 128 bit, 192 bit, 256, any kind of block we can take. There are these. It doesn't mean that we are taking 3 inputs. We are taking any kind of block size. It's up to the algorithm. Add a secret key and a plain text. If your secret key is a 256 or more, then it is good enough for the strength, but it will take more computation time. So it's up to the implementation part how much you want to be secure. Then secret key plain text, we generate the cipher text, and in the decryption side again we use the same key to decrypt. These are the symmetric key encryption decryption. The encryption is based on the hashing basically. So use the hashing function we are going to be implemented. Various number of rounds we require to perform the thing. Algorithm is quite popular and available into the for everyone. And this algorithm will again perform the byte substitution, shifting row wise, mixing the column, key addition, various things happen. So we'll generate the cipher text. So you can imagine how the white hat people or the people who want to prevent, how much effort they are taking, because the thing should be mathematically correct. Whatever you encrypt, at the end you will get the same message. Otherwise it's problematic, it's not worthy. But the black hat is also involved so actively. They will regularly, rigorously try all the mathematics, all the things to break or crack the algorithm. Okay, so we'll just see the design flow of a AES algorithm. We have one plain text of any of the block size. For example, we are taking 128 bit. We will add some round of keys. Okay, suppose it's a 128 bit, so we need 10 rounds of the substitution, block change, permutation, etc. We and the first round we'll add the key, perform the same, repeat the same thing again 9 times. Then we substitute the byte, shift the row, mix all the column, again perform the round key. So it depends on the key size and the algorithm. Right now algorithm is not important for us for this subject, but we know the type of the algorithm, what type of cipher text is available, what type of algorithms we have. Okay, substitution, that means we have one character here A, we replace it A with the B. So we have a substitute with which type of byte we are substituting, not all, but some selected as per the algorithm. Okay, so each round we are substituting the same word, same place word with another word. Now we shift the rows maybe toward the left, toward the right. So that is a transposition will happen in the AES thing. Then mixing the column. Okay, we are mixing the column to the cipher words or some other words by the padding, adding some additional keyword. Again, we add the rounds key, how the keys are performing. Okay, then we'll get the one ciphertext. If we repeat all the things, we'll get the plain text. That is the AES. But the drawback is in this algorithm is that the again key size, and this algorithm is again a symmetric key based algorithm. That means the encryptor and decryptor both are going to be use the same key. That is a difficult one. If both are using the same key and the key is leak, then whatever mathematics or whatever algorithm you have, it doesn't make any sense. So the only problem is that the symmetric key, and mostly they are using the XOR in a combination. So people can try if key size is less, so it is easy to break. Other than this, we have a asymmetric key algorithm. Asymmetric key algorithm, that means we are using two different keys. Now these days securities are made through this one only. And if you go to the bank, so they will give you the OTP, etc. So we have two different keys. One is a public key and one is a private key. So sender will use one key, and the receiver is use another key. If sender is using public key, receiver will use the private key. Private key is known by only the sender and receiver. And public key is available in a public platform. Everyone should know. But they are coming from the trusted resources. Okay, that is in a bank. In a bank, if you open your internet login ID password, so your ID is a private key, the password is private key. Once you put the private key, bank will also match it with their public key. They send the OTP and they will match. Okay, so thing is okay, then they will allow you to decrypt the message. Most of the security solutions uses this asymmetric key methods. There are various algorithms come into the picture. One of the most important algorithm in this category is Rsa algorithm. Okay, so Rsa algorithm is basically a mathematics. In Rsa there is a mathematics behind that. So that algorithm is known by everyone, but the only difference is the variable that we are going to take, and the length of the key is important. So how to generate the algorithm through RSA? So there are 3-4 step method. Okay, and this point I am suggesting you just keep concentrate on that. Maybe some numerical or some assignment based on this you have to do. Okay, so in this key generation algorithm we have two variables P and Q. So P and Q both are the prime numbers and they are not equal. Okay, just consider P and Q both are the prime numbers and they are not equal. You will take any kind of prime numbers. If you want to do it now, you can take any prime number. Let's suppose P is 3 and Q is 5. Okay, and you calculate the n. N is a multiplication of P and Q. So we have 5 and 3. We'll do it the same time. Let's suppose P is equal to 3 and Q is equal to 5. Then we calculate n, that is 3 into 5, that is 15. Okay. Now we calculate the phi of n, that is the P minus 1 into Q minus 1. So we already have P is 3, so what will become? This will become 2 into 4, that is 8. Now we select an integer, any number. Okay, which is range greater than 1 and less than equal to 5n. That means in our case 5n is 8. So we can take any number in between 1 to 8. So let's suppose I will take 3, or 3 is already there. We will take 2 number. So our calculation will be easy. E is equal to 2. Okay. And the important thing is that the GCD of phi n and E should be 1. That means your key should not be, E should not be divided, do not divide the phi n. 2 divides 8, so it is not useful. So we'll take, let's suppose we'll take 7. E is 7. So GCD is 1. So E is 7. Okay. Because whenever you select the integer E, it's a GCD with the phi n. That is 8. It should be 1. And the range in between 1 to less than equal to phi n. Okay. Now we have to calculate D. How we calculate the D? So that is E mod phi n is equal to 1. That means you multiply one word with E such that whenever you take the modulus of phi n, it should be 1. D into E mod phi n is equal to 1. So in that way you have to calculate the D. Okay, if you have that number, let's suppose E is 7, so what happened? 7 into 8, 56 will become 0. How it will become 1? So you can take any number x into 7 modulus 8 is equal to 1. And that means x into 7 divided by 8. 8 divided by 7. So you have to calculate D according to that.